All right, so now we're going to be using cosine, the cosine ratio, to find missing sides. We'll use cosine when the side we know is either the adjacent side or the hypotenuse, and the side we're looking for is either the adjacent side or the hypotenuse. All right, so we're using cosine because we know the hypotenuse and I'm looking for the adjacent. All right, so of course the hypotenuse is opposite the right angle. The adjacent is next to the angle. When we write our trig function, when we write our equation, it is always trig function of an angle equals a ratio. And because we are using cosine, that ratio is going to be the adjacent side over the hypotenuse. All right, so our trig function is cosine. Our angle is 67 degrees. And the ratio is adjacent over hypotenuse, or x divided by 52. All right, so now let's multiply both sides by 52 to eliminate the 52. All right, so now we have 52 cosine 67 equals x divided by 52 times 52. The 52's cancel. And so that gives us 52 cosine 67 equals x. And so now we can use our table. By the way, another way you can think of the solving, if you like, working with proportions, you could think of this as a proportion, and you'd cross multiply, and you'd have x equals 52 divided times cosine 67. So notice it's the exact same thing. All right, just wanted to bring that up to you. All right, so I actually found my table that matches yours. I found my better table that has the 4 decimal places. I called it trig table new. And it's right there. And it looks just like yours. All right, so we're going to find the cosine ratio, cosine 67. And so I am just going to leave this up here for a second. And you can use the one in your notes as well. And the tape will pause, and you're going to tell me the cosine ratio of a 67-degree angle. All right, so it already paused, and now I'm back again. So cosine is second. Here's our 67-degree angle. All right, so if I go across, okay, cosine was right here. So if you say 0.3907, you got that one correct. All right, can't see the little lines separating them, so it's a little harder for me to kind of go across. So we are going to replace cosine 67 with the ratio 0.3907. All right, so that would mean that x equals 52 times 0.3907. I did say, well, you know what? When I do it with the calculator, I'll double check it. All right, so let's plug that into a calculator. And look how fast we're doing these now. All right, we're getting faster at these. Once you've done a couple of them, it's kind of the same steps. It's just a different trig ratio. All right, so this would be 52 times 0.3907, and that is 20.3164. So we're solving for a leg, so we know it's got to be smaller than the hypotenuse. All right, now if we're using in the calculator, right, so in the calculator, you would simply type in 52 times cosine 67. If, of course, your calculator is backwards, then you may have to type in 67 first, then cosine, and then times 52. And that's exactly what I'm going to have to do. But that's okay. All right, so I can check that cosine ratio, make sure I write down the right value when I hit the calculator. So we have 67 cosine. All right, so notice 0.3907, we wrote that down, right? And then times 52. So that is So using the calculator, we had more decimal places. We had 20.31, and we'll round to 4 decimal places. 20.3180. So we're close, right? It took to the 3rd decimal place where we got a different answer. All right, let's try the next one. All right, so use the cosine ratio to find the missing sides. We're using cosine because we know the adjacent, right? So the adjacent is next to the angle. This is adjacent, and we're looking for the hypotenuse. So the only trig function that we know how to use that includes adjacent and hypotenuse would be cosine. Anyway, we would want to use that. It's certainly the only trig ratio that is in the calculator, right? In the calculator, there's sine, there's cosine, and there's tangent. So it has to come from one of those 3. The one that uses hypotenuse and adjacent is cosine. So we write our equation. Remember, it's going to be the trig function of the angle equals the ratio. And as a reminder, cosine uses adjacent over hypotenuse. So the adjacent side is 50. The hypotenuse is what we're looking for, x. Whether you cross multiply, right, or multiply both sides by x, you'll get the exact same thing. So we would have x, so we have to get rid of the x, which get that x out of the denominator. So that means we're going to multiply both sides by x. Don't multiply both sides by 50 just because we multiplied by a constant in the other one. That would just give you a 50 cosine 20 equals 2500 over x. How did that make the problem better, right? That wouldn't make the problem better. But getting that x out of the denominator would make the problem better. Right, so you guys think smart. Now it's all about thinking smart when we're solving here. Right, that x's cancel out, and now my x is no longer in the denominator, so now I can solve. I can't solve for it in the denominator. Right, so we have x cosine 20 equals 50, but now we have a number being multiplied by x, so let's divide both sides by cosine 20. So really, your solving is going to follow one of 2 ways. It's in the numerator, and we multiply both sides by the denominator, and we've got our variable isolated. Or it's in the denominator, right? We multiply both sides by x to get it out of the denominator, and then we divide by that trig function. That's going to be a coefficient next to our angle, next to our variable. So now we have x equals 50 divided by cosine 20. I'm going to put that table up. You use the one in your notes, or you use the one up here. I'll leave it up for a moment. And you find the value of cosine 20 that I should use. Oh, here, look at this way. So handy. And meanwhile, I'm going to erase that. Excuse me. I'm going to erase this one. But I think I've left it up here long enough for you to find cosine 20. So you're going to type that when the question prompts you. And I'm going to pause the tape. So the tape will pause. You'll put your answer in. Right? And now the tape is paused and we're back again. Right? So what value should you have typed in? Here's the 20-degree angle. And so you should have typed in 0.9397. That's the cosine. That's the ratio of the adjacent side and the hypotenuse, right? So notice that's a pretty big decimal. And that's because the side opposite so we use the adjacent side, right? So the angle opposite that side would be a 70-degree angle. So that's a pretty big angle. And that's why you got such a big cosine ratio there. All right, so we're going to use 0.9397. We'll replace that cosine 20 with 0.9397. And then we just have to plug that into a calculator. And then I'll review finding it with the just finding it with the calculator. Because you can do that too. But I want you at least to understand the table. Oops. I am looking for my calculator so that you have that if you need it. All right, so 50 divided by 0.9397. And so we get a pretty big side. And that's because we're looking for the hypotenuse, right? And the hypotenuse has got to be bigger than 50. So we have 53, oops. Sorry, I forgot when I go to write, and I never looked at that last 3 decimal places. So 53, and then we'll round to 4, 0.2085. That would round up. There we go. If we get our answer from the calculator, remember I'm going to have, because I have that backwards calculator, I'm going to have x equals, so I'd have 50 divided by parentheses, and then I'd have to hit 20 cosine close parentheses. All right, if you don't have a backwards calculator, then you can do 50 divided by cosine 20. I might still use parentheses just to make sure it divided by all of cosine 20. All right, so let's get that calculator back here. There we go. So we have 50 divided by parentheses 20 cosine. So there's our cosine ratio. Close the parentheses. And we get, and I'll take it to 4 decimal places again, 53.2089. All those 9's going to round up. So 53.2089. That takes us all the way to the 4th decimal place before we see any difference. All right, so I'm fine with the answer from the table, and I'm fine with the answer that you get from the calculator. Okay, and so long as you solve it out, so you've isolated your variable. Otherwise, you're just kind of guessing what to plug in. All right, so when I'm grading these, I look first for I grade for your equation, I grade for your work, and then I grade for your answer. So your answer is only worth 1 point. Right? The rest is worth points. And when you get to college, not only will you have your equation, your work, and your answer, then you'll justify it and prove to me why that should be the answer. That would be a different question, obviously, because this is high school math and you'll be doing college math, but still, right, it would be the same steps, but with a justification. All right, so here we're going to use cosine to find our missing side. We use cosine because we know the adjacent. Right? This would be the adjacent, well, go this way. This would be the angle of reference here is the 42 degrees, because we always start with an acute angle, never the right. And opposite the right angle is the hypotenuse. So we are looking for the hypotenuse. All right, so we always start with our trig function. So since I'll write the cosine ratio here. So remember, cosine is adjacent over hypotenuse. All right, so we start with our trig function, cosine of our angle. So cosine 42 equals, the adjacent side is 6, the hypotenuse is x. We'll multiply both sides by x to get the x out of the denominator. All right, so now the x's will cancel, because if you multiply by x and divide by x, it just cancels each other out. And so now we have x cosine 42 equals 6. To get x all by itself, we'll divide both sides by cosine 42. So now we have x equals 6 divided by cosine 42. So that's 6 divided by, all right, let's find cosine 42. All right, so I'm going to pause that. As soon as I find it, I'm going to pause the tape a little bit, or just kind of wait for you. You can use this one, or you can use the one in your notes. You can look while I am erasing my angle there. So I have to remember how these go. Remember, when we're looking at the table, right, they're always listed sine, then cosine, then tangent. All right, so you find the value for the cosine, the ratio, that decimal for the cosine of a 42-degree angle. And when the tape pauses, you'll put your answer in. All right, so hopefully you saw the 42-degree angle here. Very slyly just kind of made sure I moved the screen up so you could see it. And then cosine is the second one. So 0.7431 is our value that we're going to replace cosine 22 with. That's 0.7431. Oh, excuse me. Did I circle? Yeah, 42. I said 22, but I circled 42, so it's okay. 0.7431. So we'll replace that. So now we can use the calculator to find the length of the hypotenuse. And we're obviously going to get something larger than 6. Well, first of all, because it's the largest side of the triangle, and second of all, if you divide 6 by something that's between 0 and 1, you're going to get a greater value. Right? I'm dividing it by smaller pieces. So we have 6 divided by 0.7431, and that is 8.0742. Oh, excuse me, 3, but round up. So it's 8.0743. It doesn't like to write when I switch applications. All right, so in the, oh boy, we should have a lot of space. I'll just do it right next to it. In the if we find the value in the calculator only, and we use that to evaluate rather than the trig table, right? We're going to be just a little bit more precise, right? Because it has more decimals in the calculator. That's the only reason. All right, so again, I have to use the parentheses because this is the backwards calculator. Oops. Oh, there goes my calculator because I moved x over just a tiny bit. All right, so we have 6 divided by parentheses 42 cosine, close the parentheses, and notice that's the cosine ratio there, equals 8.738. 8.0738. Okay. Again, it took us, so pretty close, 8.0743, 8.0738. Okay. And that's all there is to finding missing sides using trig ratios. Now we're going to do a word problem, and we're going to need to use more than just cosine. You are constructing a skateboarding ramp like the one shown below. Your ramp will be 8 feet long and the ramp angle will be about 22 degrees. Find the lengths of the legs of the triangles that support the ramp. Round your answers to the nearest inch. You know, I don't like to round quite that much. Let's say nearest hundredth of an inch. We can do that. I can do that because it's my problem. All right, so let's first find x. Notice where x is located, right next to the angle. That is the adjacent side. Y is across the triangle. That's the opposite side. Then, of course, across from the right angle is the hypotenuse. So notice that for finding x, let's solve for x first. I'm going to just use a different color. So I labeled in blue. I'll write solving for x in green. So we're going to solve for x. Notice that we are missing the adjacent. So x is the adjacent. We have the hypotenuse, right? 8 equals the hypotenuse. So if we're looking for the adjacent, but we know the hypotenuse, we should use cosine. So we have cosine 22 degrees equals the adjacent, which is x, divided by the hypotenuse, which is 8. Let's multiply both sides by 8 so that we can isolate x there. So there the 8's cancel out. So now we have 8 times cosine 22 equals x. All right, so let's go look at our table for cosine 22. This time, I'm not going to pause the tape for you to answer. We did that a couple times. So here, if we look at our table, right up here is cosine. Let me get rid of this. Right up here is cosine 22. So there's 22-degree angle. Cosine is the one in the middle. So 0.9272. So now let's And we may as well keep that circle because we're going to need it for the next problem, because we're still going to be dealing with the 22-degree angle. So we have x equals, so we're going to multiply 8 by cosine 22, which was, I did very good with not forgetting numbers. And I guess I went too quickly and I kind of forgot the number. It was 0.9272. And I think this time we'll just do this one. We'll just do this one in the with the table only. Maybe we'll do the next one with the calculator only. That sounds fair. So we have 8 times 0.99272. So that is 7.4176. And since we said the nearest hundred, 7.41. So that would be 7.42. All right, so now let's solve for y. All right, so y is the opposite side, right? And the side we know is the hypotenuse. Do not use x to solve for y. There's no reason to, and it would create rounding error, right? We know that we rounded, right? We rounded to get x, right? If we then calculate with the rounded value, we're going to create even more error when we go to solve y. All right, so always go with your exact answers, right? So that you don't have rounding error. So we are going to use 8 again. That's an exact answer. Why would we want to use 7.42 anyway? We're going to use the 8. So we are looking for the opposite. We know the hypotenuse, that's sine. So we have sine 22 equals y divided by 8. Multiply both sides by 8 to isolate y. All right, so those 8's cancel. So now we have 8 sine 22 equals y. All right, so now let's go find out what the sine ratio was for the 22-degree angle, and we can plug it in there and calculate. There we go, and it's still circled, so it's 0.3746. .3746. Right, we'll grab the calculator and we will calculate out that measurement. So 8 times 0.3746 is 2.9968. Well, we said we would round to the nearest hundredth, and so that's going to be 3, right? Because everything will keep rounding up. So our answer here for y is 3. Right? And then we have solved for our missing sides. All right? So now we're going to do 2 more problems, and both of them involve more than just cosine. And this time we're just going to use the calculator. So on this problem we use the table. On the next one we'll just use the calculator. All right, so here we're looking for A and B. All right, so let's solve for A first, and we're going to use the angle that we were given here. So very first thing let's do, let's label our sides relative to our angle. Across the triangle is the opposite side. Next to the angle is the adjacent side, and the hypotenuse is always opposite the right angle. All right, so here we know the hypotenuse. So the one trig function you should know we're not using is we're not using tangent, right? Because tangent doesn't use the hypotenuse. And we're looking for the opposite. Gee, who uses opposite and hypotenuse? Could it be sine? Absolutely. All right, so now let's write our equation. So we have sine 56 equals opposite, which is A, divided by hypotenuse, which is 24. We'll multiply both sides by 24, so we have 24 sine 56 equals A divided by 24 times 24. We cross off the 24s, and we have 24 sine 56 equals A. This we're going to plug right into the calculator. All right, so let me go grab it. All right, so we have, maybe I should have solved, you know what, so I don't have to do it, no, you know what, never mind. I was going to say, maybe I should just find A and B with the calculator both at the same time. However, the problem with that is I won't remember the numbers, so. So we have, oops, getting my foot caught in the cord here. Hopefully I won't pull that out. Or even worse, knock the computer over. That would be really bad. All right, so 56, I have to start with the angle because it's backwards, times sine, and then times 24. So that one is, we'll round to 4 decimal places, 19.8969. 19.8969. All right, so now let's find B. All right, so to solve for B, B is the adjacent side. We still know the hypotenuse. All right, no, I'll put it down here. So we know the hypotenuse. We still know the hypotenuse. We would never use A because that's a rounded value. Remember I said we'll round to 4 decimal places. When you calculate with rounded values, then you create error. But if we use 24, which is a nicer number anyway, we won't create any error, any additional error from rounding. So we know the hypotenuse. We're looking for the adjacent. Who could it be that uses adjacent and hypotenuse? Why, of course, that is cosine. By the way, I've been kind of neglecting telling you all through this that which problems are in your notes. So let me just say that all of them are. All right, so hopefully you've been taking very good notes. All right, so now let's set up our equation to solve. I'm going to solve up here because I have a little bit of space over here. So we have cosine 56 equals B divided by 24. Again, we'll multiply both sides by 24 to isolate our variable. 24s cancel out. So now we have 24 cosine 56 equals B. Let's plug that into a calculator and get that measurement. Right? So on these last couple, we'll just use the calculator since we've just solved all the others 2 different ways. All right, so this is going to be 56 cosine, there we go, and then times 24. So that is 13.4206. So notice that that side is smaller than the other leg, which makes sense because this angle here is only 34 degrees. And remember, smaller sides are opposite smaller angles. So there we go. All right, so we have solved for A and B in this triangle. I think I have one more that we're going to solve for. Either that or this is the last one. One or the other. Let's find out. Nope, I got one more. All right, so let's solve for C here. All right, so here's our angle. Next to the angle is the adjacent side. And C is the hypotenuse. All right, so we know the adjacent. We're looking for the hypotenuse. Who uses adjacent and hypotenuse? Well, of course, that is cosine. All right, let's set up our equation. So cosine of an angle, cosine 18, equals, and remember cosine is adjacent over hypotenuse. So 124 divided by C. We got to get the C out of the denominator first, so let's multiply both sides by C. So we have C times cosine 18 equals 124 divided by C times C. the c's cancel out. So we have c cosine 18 equals 124. Divide both sides by cosine 18. Right, and so yeah, squeeze that in there. Can I move this down? I think they're attached. Oh, no, I can squeeze it down because I'm going to do the problem up there. All right, so c is equal to 124 divided by cosine 18. Now, this side is opposite a pretty small angle, so it's going to be a pretty small side. Let's get our calculator. So I have 124 divided by parentheses. I got to hit the 18 first because this calculator is backwards. Cosine, close the parentheses, equals, and we get, oh, excuse me, we're solving for the hypotenuse. A is going to be a pretty small side because it is opposite a really small angle, but C is the hypotenuse. I forgot which one we're solving for. So C is going to be bigger than 124, and C is 130.3813. And now for the last one here. All right, so we need the opposite. Of course, we're not going to use that rounded value. We're going to use the value we know, which is the adjacent side. So we know the adjacent. We're looking for the opposite. Who uses opposite and adjacent? Well, of course, that is tangent. All right, so I think I can squeeze it right here. So tangent 18 equals A divided by 124. Remember, that's opposite over adjacent. Multiply both sides by 124 to isolate A. So we have 124 times tangent 18 equals A divided by 124 times 124. That, whoops, I said times 124 and then I write times A. My hand was not listening to what I said. So that will cancel out. That gives us 124 tangent 18 equals A. So that means A is our last problem, finding sides. And then we're going to be finding angles and finding sides and angles and solving word problems and all kinds of cool problems. So this is, I got to go backwards, so this is going to be 18 tangent times 124. So I told you to be pretty small relative to the fact that the other sides are 124 and 130. So this is 40.2900. Oops. And there we go. That's our last problem. Right? And so thanks for watching. Solving for missing sides using cosine. And we got a little review of sine and tangent as well. So thanks for watching and bye for now.